Okay, so this question says a 20 milliliter sample of gas is at 546 Kelvin and has a pressure of 6 atmospheres. If the temperature is changed to 273 and the pressure to 2 atmospheres, the new volume of the gas will be. So when I read this question, I have to decide on which formula we're going to use. We can use combined gas law, we could use ideal gas law, or we could use Dalton's law of partial pressures. That's a very important decision because step one says you have to write and rearrange your formula. Well, when I read the question, I'm realizing that the gas is changing, right? So if I know that the gas is changing, that means I need to use combined law, which is P1, V1, T2 equals P2, V2, T1. So the variable that I'm solving for, because I still have to rearrange this formula, it says the new volume. So that means my second volume. So using simple algebra, I'm going to move P2 and T1 over to the other side so that V2 is isolated. Okay, I'm just going to clean this up a little bit. Okay, so that's step one. Get the variable that you're solving for isolated. Okay. Step two is to check for any conversions. Remember that volume needs to be in liters, temperature needs to be in Kelvin, and pressure needs to be in atmospheres. When I read this, it looks like I'm good, except for one thing. I was given 20 milliliters, so I have to convert that into liters. So I do that by doing 20 milliliters to convert it, 1,000 milliliters to 1 liter. That equals 0.02 liters. Okay. So when I'm ready to, now I'm ready to substitute. So I'm just going to make some space here for myself. Remember that it's 0.2 liters now. And I go back to my question and cross out 20. Oops, that was a big cross out, but whatever. 0.02 liters sample of the gas. Okay. So now I'm ready to plug in. Y'all have been doing really great with this setup where you pre-write down everything, all your variables before you actually plug it in. So let's continue that. Okay. My pressure number one was 6 atmospheres. Volume number one, remember we had to convert that, that's 0.02 now. Temperature number one was 546 Kelvin, which is really hot. Okay, pressure number two was 2 atmospheres. Volume number two is what I'm solving for, so I'm going to put a question mark. And second temperature was 273 Kelvin. Okay, ready to do step three, where we'll still on step three, we're going to plug it in to the rearranged formula. P1, 6, V1, 0.02, T2, 273. Be very careful there. I've seen a lot of mistakes with people putting temperature in the wrong place. This was T2, right? So I had to put 273 because T1 is going on the bottom. P2 was 2, T1 was 546. Okay, so let me go ahead and calculate that. in my old calculator that I have here at home, so it takes me extra time because I don't have all that fancy stuff that y'all have at school. And I get my answer to be 0.03. Okay, so that's 0.03 liters, right? The question asks for it into milliliters. So what you're going to do is, let me make some space for you right here. If my answer is in liters, right, and they're asking me liters, then I just need to convert it back into liters or milliliters. So 0.03 liters multiplied by 1 liter on the bottom, because I got to match my unit, equals 1,000 milliliters. So I'm basically doing 0.03 times 1,000. And that gives me my answer, 30 milliliters.